In this video, I want to introduce the concept of a motion diagram. In this unit, our sort of qualitative description of motion, the motion diagram plays a central role of that understanding. Okay, so what are the components of a motion diagram? A motion diagram is like a movie of the object's motion. So it's like a movie of the object's motion, where you don't see where the frames are rare enough that you see discrete motion instead of continuous motion. So it's like a movie, only we see separate frames of large time intervals so we can see discrete motion. So another aspect is that each frame, that's important, each frame is equal time intervals. So I mean, a better way to say that, there are equal time intervals between each frame. And so we see how how the motion is by a regular clock. All right. And so to do most of our diagrams, when we plot them, we're going to look at a couple important, within another important concepts, which is we want to look at the motion diagram relative to a coordinate system. Most often. So this is not a necessary part of a motion diagram, but we often want our motion relative to a coordinate system. And also we're going to invoke the particle model. A particle model essentially means we represent our object by a single point in space. To emphasize, a particle model means the object has mass but no volume. That also means necessarily no structure. I can represent my object by a single point in space, which is what I mean by a particle. So let's do motion diagrams for sort of our four objects in motion that we want to look at. Okay, object A, we're going to say, is a toy car speeding up on a table. So if I were to draw that picture, what I might see in that movie, I have a ground, sort of a table, and in this case, my car, which is represented by a particle, might start at one point, and then at one frame later would be here, one frame later would be here, and one frame later would be there. So my object, which is represented by a point, and I'm showing where it is at equal time intervals. Right. My next one is I want to look at, I can put a coordinate system on this. For example, for this I might want a one-dimensional coordinate system, put my 0 where the object starts, and say have plus x off to the left. So my next system might be, this is we'll say throw ball from, what do we say, second story of a building. So in this one, so here's this building, here's the person, here's the second story, and we'll call positive x, positive y, and this ball is being thrown represented by a point. It might be here, and then some equal time here, then where do I want? Here, here, and then here, 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 here. That may not be the greatest drawing, but now this is snapshots of equal time intervals of a ball being thrown from a second story. The same idea. I've got representing my ball by a point particle, and I'm looking at where it is at equal points in time. Okay. The third example, and in this one I've got a ball on a string that I'm swinging vertically. So what does that look like in a motion diagram? Well, I might have a coordinate system here. In fact, I might just draw all my axes. So here's plus x, plus y. And I might find that at t is equal to 0, then the ball is at horizontal. And then at some time later, it's swinging in a circle. And so it's going to be, say, maybe it might be here at another point in time, then maybe here, then maybe here, then maybe here, 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 then we're here. It doesn't quite add up on itself. And then maybe here. So I don't want it to get too, now it's going to get confusing. But it's on the same path, though it may not line up on exactly the same dot, depending on how fast it's going around in a circle and what my time interval is. But this is now the motion diagram for a ball on a string swinging vertically. I've got x is horizontal to the ground, y is perpendicular to the ground, and at equal intervals in time, I would see a snapshot of the ball on different parts of the circle. Right. My last sort of example is a mass on a spring. This is supposed to be pretty easy. Just introducing this concept of a motion diagram, which is just giving us snapshots in time. So this is, if this seems like, okay, this is not, why is he spending so long on it? That's just introducing the concept here. Okay, so on this one, and also putting it together with coordinate systems. So in this one, I might say that the object, green here, starts at some point here, and if I look at some time later, it might be here, then sometime later, and later here, and then it swings on the other side, where it comes to a rest, and then I might see it completely repeat itself. And this sort of motion diagram, I've got it at each point in time. It looks at exactly the same place it was at some other point in time. It doesn't have to be that way. I mean, it could have been like the circle, where the period of one revolution did not exactly match up with integer numbers of my time steps. But here I'm going to say that one period of the oscillation maps up with the time steps. So as it goes back and forth, we see snapshots repeating itself at different points on the oscillation. But the idea is the same. Again, where we have a motion diagram is just a series of these snapshots put together with a coordinate system that we might be able to analyze its motion.